Hello students, in allotropes of carbon we have the third one is what? Fullerenes. Okay. Now let us see the preparation of fullerenes. Here fullerenes are made by heating of graphite in an electric arc in the presence of inert gases such as helium and argon. Okay. Simply you are taking the graphite. Okay. Graphite in the what? In the electric arc, one type of operator. Okay, in presence of what you are going to use the inert gases, what? Helium and argon. Now, so what happens once you heat the graphite? It is going to form some sooty material. Okay, like a messy type. Okay, that is what happened at undergo condensation, and mainly it is going to what? Give the, here you can see, formed by the condensation of vaporized Cn power of n small molecules consist of mainly C60 with a small quantity of C70, and traces of fullerenes consist of even number of carbon atoms up to 350 and above. Here simply you are taking the graphite, you are going for the heating in presence of helium and argon. Okay, so what happened? You are going to get some sooty material that is undergo condensation, means they are going to add together up to what depends on our requirement. Mainly, so you are going to get the all carbon 60 carbons are going together, add together, and you are going to get the fullerene. Sometime what 70 carbons are going to add condensate together, and sometime what happens 350 and above. So like that you are going to prepare the fullerenes. Now if you see the structure of fullerenes here, it is an allotrope of carbon containing cluster of 60 carbon atoms. As we told, we have the total how many carbon atoms in the fullerenes means 60. They are joined to form a spherical molecule, like a spherical. Okay, as you know very well, spherical shape. They are going to form the what? Spherical in shape. 60 carbons are arranged in a what shape means spherical shape. The C60 molecule has a shape like soccer ball and is called Buckminster fullerene. Okay, here what happens? C60 means 60 carbon atoms. The fullerenes, as you know very well, we have 60, 70 carbons, like, okay, so on it is there. But what fullerene, Buckminster fullerene, what you are calling as a Buckminster fullerene for the what? 60 carbon atoms, and it has a shape what? Soccer ball. Here you can see the soccer ball shape. Okay, this is a soccer ball, and this is the structure of what? Fullerene. You can see here, see, we have the what? Pentagonal ring. Here we have the pentagonal ring in the ball, and we have the hexagonal ring. Okay, here you can see the hexagonal rings. So like it is going to match with the what? Our soccer ball. Here you can see. Okay, here around the pentagonal ring we have the hexagonal ring. Here you can see these are the hexagonal rings. White one. Okay, black one is what? Pentagonal ring. Pentagonal rings. It contains 26 member rings and 12 5-member rings. So here you can see, so here we have the what? 20 and 12 hexagonal rings are there, like that you can count here. Okay, so in the C60 spherical shape of fullerene, so 26 member rings and 12 5-member rings. All the carbon atoms are equal and they undergo sp2 hybridization. Here also, like our graphite, in fullerenes also carbon undergo what? Sp2 hybridization. So once, as you know very well, sp2 means shape is what? Trigonal planar. Okay, in that trigonal planar we have one unhybrid. This is trigonal planar, and we have the unhybrid p orbitals. Okay, having the one lone pair of electron. So each carbon atom forms 3 sigma bond with 3 other carbon atoms. So they are going to form the what? Now these 3 going to form the what? Sigma bond with the another carbon atom. The remaining electron at each carbon atom is delocalized in the molecular orbital, which in turns give an aromatic character to the molecule. Simply means here also the unhybrid orbitals giving the what? Aromatic character. Actually aromatic character means, for your stage, aroma means good smell. Okay, but here as you go for further studies, you can come to know what is aromatic character clearly. So I am not going to discuss detail here. The ball shaped molecule have 60 vertices and each is occupied by one carbon atom. So here you can see like this, we have the vertices, nothing but molal. Okay, that is surrounded by the what? Each contain the what? Carbon atoms. and it also contains both single and double bonds with a carbon-carbon distance how much? 143 picometers and 138 picometers respectively. So as you know very well, single bond length will be more and double bond length will be less. Okay. So this is about single bond, this is about the double bond. Spherical fullerenes called as a buckyball. So spherical, as we told, the 60 carbons are arranged in the what? In spherical shape. We have different space. But here what? If you have the spherical in shape, that type of fullerene is called what? Buckyball.